Hello, let's take a look at page 3 of your practice test. And on question number 12, we want to find S to R. And notice it's an angle bisector. So we're going to apply the angle bisector theorem. So this is kind of like the problems you did on Alex. That is, we know S to R is X. I'm going to say P to X is going to be 40 minus X. Now we can set up a proportion. I'm going to say X is to, and I think I'm going to go 12 as 40 minus X is to 30. And then I will find the least common multiple of 30 and 12, which is 60. So I'm going to multiply both sides of my equation by 60. 12 goes into 65 times, so I'll get 5x. 30 goes into 62 times, so I'll distribute that 2 to my numerator, so I'll get 80 minus 2x. I'll add 2x to both sides. I'll get 70, not 70, let's try that again. 7x equals 80. So in other words, if I divide both sides by 7, x would be 80 over 7, and that is S to R. And there's our answer for question number 12. Okay, in question 14, we're going to use the fact that, notice we have similar triangles, and I want to find the value of the x, which is an altitude of g to h. Well, remember, your altitudes are proportional if the triangles are proportional. So we'll say x is to 7.5 as, well, try that again. How about 4.5? That's the altitude. As 12 is to 7.5. And I think what I'll do is I'll multiply both sides by 4.5 and 7.5. Since they're decimals, we'll just clear our fractions. So we get 7.5x equals 12 times 4.5. So 12 times 4.5, 12 times 4 is 48, plus 6 would give me 54. Then I'll divide both sides by 7.5. So x is 54 divided by 7.5. I think we'll do that as a decimal. So if we take 54 divided by 7.5, we get 7.2. And there is our answer for that question. And number 15, we want to find the ratios of the perimeters of FGH to JKL. So I'll pick two sides. I could have picked the altitudes, but I'm going to pick my two sides. I'm going to say 12. Whoops, I always forget to change the highlighters when I use the highlighters for some reason. So we'll say 12 is to 7.5, which is 120 is to 75. I do believe I can divide both of those by 15. So if I take 120 divided by 15, I get 8. 75 divided by 15 is 5. So our similarity ratio for the perimeters is the same as the scale factor. So it is 8 to 5. Please notice we had to go in the order of FGH to JKL. That's probably the one thing that people get a little confused on. On question 16, we are told that DE is parallel to AB, which means the sides are cut in proportion. So I'm going to say 2x minus 4 is to 5x as 3x is to 8x. Now I can't reduce my x's on the left because the 4 doesn't have an x, but I can reduce them on the right. So we get 2x minus 4, 4 is to 5x, as 3 is to 8. And then I'll clear my fractions. I'll multiply both sides by 5x and 8. Notice on the left side we'll get 5x, so we distribute that 8. So 8 times 2 is 16x, minus 8 times 4 is 32. Equals, on the right hand side, the 8's reduce. 3 times 5 is 15x. Then I think I'll do is I'll subtract 16x from both sides. We end up with negative 32 equals negative x, which really means x equals 32. Then I want to find a to d. So then, to find a to d, we're going to replace x with 32. So I'm going to say 2 times 32 minus 4. So 64 minus 4 is 60. And there is your answer for A to D. Now on question number 17, we want to find the scale factor. Well, notice I already know my image WX has 4/5. So to find my scale factor, I'm going to take my image divided by my pre-image, which is 4/5 times 3 over 2. 2 goes into 4 8 times. So your scale factor for the dilation is going to be 24 over 5.